So now I'd like to introduce our opening keynote, Gayle Sheppard, to the stage. Gail is currently the founder and executive chair of New AI Co. Most recently, she was the vice president and general manager of Intel Saffron AI Group, where she led the overall market vision, strategy, and growth of reasoning systems based on memory-based representation and reasoning technology. Prior to Saffron, she built a career in the enterprise software industry as vice president at PeopleSoft, CEO and president of Market Mile, an American Express-funded startup that provides online procurement services to its customers, and at J.D. Edwards as VP Worldwide Sales, President, and General Manager of J.D. Edwards Japan, and Vice President J.D. Edwards Asia Pacific Limited. Gail is a graduate of the University of South Florida, Tampa, Florida, where she received a BS in Business Administration with a focus in Operations Research and Management Science. She currently volunteers for the National Center for Missing and Exploited Children. Let's welcome Gail to the stage.
Well, good morning. I am delighted to be here. I lived in the Research Triangle for 10 years as part of my journey in AI. And in 2015, I officially relocated to the Bay Area and live in San Francisco today because Intel acquired Saffron, which was a company started here in the Research Triangle and headquartered in Cary, North Carolina. So it's always delightful to come back. Let's see if I can operate my slides. There we go. Perfect. So first of all, this is a beautiful venue. I didn't realize this was brand new headquarters, but it is quite gorgeous and well designed. So it's lovely to be here, and it's also lovely to be the keynote at your first Springboard conference. So I appreciate the opportunity to do so. I was with Intel until last week. My last day was October 15th. And so I had the pleasure of working for this great brand manufacturing company and to bring AI systems, software systems into that organization. Today I stand here as an unemployed person. I am starting a new co with some folks from the Raleigh area as well as in the Bay Area. And we're really looking to build the next generation of enterprise decision systems. So very much focused on B2B enterprise systems. So you'll hear a little bit of that bleed through the talk today. But what I'm hoping to do is just share with you some observations and some information I think might be useful to you in the variety of discussions that you're having in these 2 days. And these discussions are quite impressive, and I'll hit on some of them as we move along. So let's go ahead and get started. Let me share a little bit of my journey with you so far. And I really appreciate, by the way, this setup here is perfect. I would be considered a tech exec, and I have had 12 years of experience now in building out AI systems and delivering them to customers and solving some what I think of as some fairly complex problems. As the journey started in 1999 for the founders of the company that I would dedicate 12, 15 years to, Manny Aparicio and Jim Fleming are the original founders of Saffron, came out of IBM here in the Research Triangle and are still resident here today. I would be in that enterprise software journey during their founding years and actually starting a company with American Express that would provide indirect expense procurement services to American Express's mid-market customers. But we would join up in around 2004, 2005. And at that point in time, what we were working on was really an analogical reasoning system. If you have read Doug Hofstadter's latest books, or one of his latest books, Surfaces and Essences, analogical reasoning is the foundation of human reasoning, and as a theme of that book. And thinking about analogical reasoning and similarity analysis is really the foundational qualities of the technology that we were building. And often we would work on problems where we had tried to, or the customer had tried to apply statistical machine learning or deep learning, not yet so much, but could not solve the problem through traditional methods. And I could be in the room with an audience of customers, which would have, chief innovation officers, data scientists, and business people, and could be viewed, I am sure, by that audience as heretical, a lunatic, or inspirational or visionary, depending on who I was talking to. So it's been an interesting journey. And so where we are today is having launched some commercial products in the market. I really believe, and I have foundationally, I like to explain kind of the context of my origins, have a foundational belief that AI does not equal machine learning, and that AI does not equal deep learning, and that AI is, in fact, an end-to-end systematic approach to trying to mimic, if you will, how we think as humans. And so that what we're really doing today, for the most part, is not AI. And I often caution your friends that when someone presents AI to them, to make sure that they're not buying AI, but they understand what you're getting, right? It's machine learning, it's deep learning. They are very much things, tools that are targeted to solve a very specific problem. We are yet to get to AI, and we're getting there, and there are some really great examples ahead of us. So we'll talk a little bit about that. Let's talk first about, I like the duck and I like the fork, because visually we would think the duck can't use the fork unless we train the duck to use the fork, right? So the fork is simply a tool, and that's how I think of machine learning today. Until we really learn how to apply it, and apply it not just as a task, but in a job, a series of jobs to be done. So, and I think that if we define what AI is, and perhaps we take a moment to just ground ourselves in perhaps my philosophy, at least, shared by these organizations as to what AI is, this would be helpful in context of this talk this morning. I think of sensing, learning, reasoning, taking action, making decisions, situational analysis, sense-making as functions of and steps along the way of an end-to-end AI system. So perception is often accomplished today through a deep learning capability, right? Our ability to understand what's in front of us. But the context of what's in front of us may not be obvious through that visual perception or that image. And so we need additional information about, perhaps there's a team of people sitting at this table right here. How are they connected? Do they know each other? Have they been at these conferences together before? What does it mean that they're here together today, if anything, right? How do we make sense of their presence? And generally speaking, that's not available in a simple deep learning or machine learning algorithmic approach to understanding who might be at the table. So we need more information. And so that ability is going to require something that I think of as cognitive synergy, maybe referred to as complementary learning, which is the ability to put together a systematic approach using different learners, whether they be statistical machine learners for some basic rules, symbolic logic, whether it be deep learning to help us with perceptual compute, or whether it be a reasoning system, a Bayesian system combined with an associative memory or reasoning system, analogical reasoning system, to provide some analysis, closer analysis into possible causal reasons for an event to have occurred. And these things come together, right, to understand what it is, how it might be related to each other, and how and where we might see it again, and what the outcomes of that could be, are part of a systematic approach to AI and what we think of as perceiving, learning, abstracting, reasoning, acting, deciding, recommending, and then we're going to add to this learning from the outcomes, the feedback loops, so that we become smarter and smarter with our own experience. So that's AI in a nutshell. And there are two organizations that were referenced there. One of them was the 100-year study, which is a Stanford sponsored program today that actually a gentleman named Eric Horvitz launched from his work as the president of the Association for Advanced AI organization back in 2008, 2009. And he worked with Stanford to actually put together what would be a group of people, researchers who are listed here, and I deliberately put their names up because this is the credit that they have asked to be given when we reference this particular program. But I think there are many, MIT has some great work, Carnegie Mellon has great work, and on we could go across the universities here in the United States, and as well as outward into the rest of the world. I just chose Stanford because I think this is a really relevant topic to what you're doing here in the next 2 days. If we look at the topics that they have, and they have 18 topics that are associated with this 100-year study, they are covering things like privacy and machine intelligence, democracy and freedom, law, which is, what are the numerous implications for law and regulation that AI brings to us, ethics, I'll touch on that again later. What are the economics? I believe the next speaker from IBM is going to be talking about economic impact of AI and business. AI and defense, AI and warfare, an important topic, one where there's an entirely new battle underway as to a arms race, if you will, using AI for this purpose. Collaborations, human-machine collaboration, machine-to-machine collaboration, AI and human cognition. What does this mean? We use the brain-like references every day, every hour in terms of speaking about machine learning and deep learning. What does this really mean, and how do we get to a more human-like approach if that's possible? Safety, psychology, and onward. So these topics that you're addressing over the next 2 days are critical to the future of how we deploy AI. And I think this particular organization is one that, if you're not aligned, it would be, from your personal work, would be helpful to do so. They obviously are predicting that AI applications will be included in self-driving cars. They're required there. Deep learning is a fundamental requirement for the advancement of autonomous vehicles. Healthcare diagnostics, we're seeing that already. Just in image recognition of tumors, for example, in radiology, we understand the complexity or advanced state of a tumor. What we now need is the ability to reason from that with its individual characteristics of the patient to determine what the guided care plan should be for the patient. That's a future action that's not yet developed into, the best I can tell, healthcare system. So we're doing some of the diagnostics. In the future, healthcare will bring us individualized, personalized care that's holistic, that takes our life into account, as well as the diseases that we're battling, as it may be. So these are things that we can expect in the future. We've done a lot of work. AI is not new. It's been around for a long time. It has had many winters and may have some more before we're all done, but nevertheless, probably in the 50s is when it really began to develop some meat, along with Alan Turing as a catalyst for that. But I think the organization here is also supporting the fact that deep learning, although it is the fair-haired child, if you will, of machine learning today, it is not the only approach. And there's been a tremendous amount of research done. I'll talk about some of it that is available to us to deploy now. So we have to learn some basic things about the world, the stable environment of the world. And once we do that, then we have a basis of knowledge on which we can really get to work on. So I think what this group is stressing is that the need to be able to take all of the research done in AI and use it as a body of work to create end-to-end systems. Now, there's also funding the future, and DARPA has been brilliant at doing so. Doesn't receive a lot of credit for it sometimes, and particularly in the Bay Area, there's a lot of discussion about how our defense organizations are supported from and by AI organizations. But it is an important body to follow and to understand what they're focusing on, because they're funding the future. So we can count on DARPA to do what they have done in the past, whether it was Siri, for example. I'm sure you know this was a body of work that was funded originally by DARPA and came out of that organization. So the internet, we could go back to many natural language processing. There are many examples where DARPA has funded advancement that have come to be great commercial tools that we are able to deploy every day in our businesses. So DARPA doubles down on AI, invests $2 billion forward in the study of contextual reasoning systems. How many use a contextual reasoning system today, or an adaptive learning system today? Anyone? We have one. One person? Okay. So I would like to hear more about that. Right. Are you with DARPA? No. Mm-hmm. Okay. So the commercial acceptance of the commercial availability of contextually adaptive reasoning systems is fairly non-existent. There are a few examples. But this is also called or thought of as a third wave. I'm going to spend a few minutes on the waves of AI and what they mean. So contextually adaptive reasoning or contextual adaptive reasoning is in fact the next wave of AI as defined by DARPA. We'll talk about why that's important. In addition, addressing security challenges, cybersecurity challenges and others are a big part of this funding. But I think this sets the stage for all of us to think about what we can expect in the next 5 to 7 years of advancement in AI. So end-to-end systematic approaches, leveraging all we've done so far in the first and second wave, and creating now an advancement of being able to reason onward using additional methods of machine learning to help us do so. I spent a lot of time in industry, I spent my entire career actually in the enterprise software industry. And so I've solved a lot of problems with customers along the way, helping bring technology to do that. I don't think ever in my life I have seen industry transformation underway as great as I see it today. From the automotive industry, where we're going from catalytic converters to batteries-driven power, and think about the ramifications to the supply chain when this occurs. The simplicity of the battery-operated car versus the original catalytic converter-driven car is pretty phenomenal. The number of parts used in these devices, if you will, these transportation devices, is fundamentally order of magnitude different, great magnitude order of different. So, and we transfer that over now to other industries where the same type of transformation is occurring. So supply chains are being disrupted everywhere. In healthcare, supply chains are being disrupted with intelligent medicines, right, and devices, patient-ingested devices alone will cause that. Amazon entering into the payer segment of the market. I'm not announcing that, by the way. They haven't announced that yet. But imagine that they do. And imagine that the payer is actually the organization that knows the most about us in terms of our healthcare. It's not your doctor. It's not the laboratory. It's actually the payer who has an aggregation of all of those events or episodes, if you will, in your life. So that's an interesting thought, right? That the payer would have the most data about you and you don't own the data. And so data ownership and data privacy, data access is a big topic for the future, and one that we will see a transformation already beginning to occur. Finance, money laundering, fraud are at a high. How do you continue to deploy AI to help solve those problems and bring more intelligence into anti-money laundering? How do you shift from a transactional valuation where there are a lot of false positives into a customer-centric understanding and peer segmentation analysis so that we can understand the customer's intent and the customer's behavior and episodes around the customer that would suggest that this is a money laundering activity or not. And reducing false positives. So a tremendous amount of work underway there. And on it goes. So every industry, we have the joy, if we're all in these industries, of being transformational artists, of helping achieve this great shift that's occurring in business. But it has, in my estimation, never been so great. And I want to pause for a moment and take you back now to contextual adaptation, because this is what you do every day in your life, whether it's your personal life or your business life. You're adapting to the situations in front of you. And you have rules and models that you work with, and then when push comes to shove, you adapt. You go into experience-based reasoning, yours and others, in order to make sense of a situation and decide what to do next about it. Now, Reinhold Messner happens to be a mountain climber. I think he lives in Switzerland now, and he's probably in his late 70s. He has climbed every major peak over 8,000 meters in the world, including Mount Everest. And when you think about these peaks, let's take a look at this one. This happens to be Mount Everest. You can imagine, it looks kind of calm, right? You can imagine that there's great topography knowledge about Mount Everest, that There are two pathways to the top, one from the north and one from the south. The south is the easiest way to get there. Many people have attempted it. Many people have accomplished it, and therefore it should be well documented, and there's some training we can do, some rules we can follow, and we can get to the top of Mount Everest. That's how we might think about it. But the truth is that stuff happens. And in a dynamic world, what looked to be very calm and sort of normal may not be. And this is a more normal scene on Mount Everest than we might imagine. But in this particular situation, I won't play the movie for you because the movie is one which is traumatic, where people are potentially dying. So, but in this particular case, we think about our lives every day in our businesses as life and death, right? We must accomplish X or, we will die. This is war, et cetera. We use a lot of terminology like this. And contextually adapting is how we survive and how we win, how we compete in the world. But you do that not only with the rules and models that have been established, the guidelines and the values that you use every day in your decision making, the ethics that you bring into that, but you also do that with one-shot learning. You also do that in context of a situation. One rule may not fit. An example would be a stop sign in an autonomous vehicle. So the rule for the autonomous vehicle is going to be, you see a stop sign, this is what a stop sign looks like in the United States, you stop. Well, what if you're driving your spouse to the hospital? Do you roll through the stop sign looking both ways, or do you stop, right? That's contextual adaptation in its most simplistic form. So we have these types of things will ultimately enter our future in every machine that we work with. So let's talk about the transformational journey that AI has been on and will continue to be on. This was documented by DARPA, a report that their CTO had published perhaps about 2 years ago. And it's really, I think, a very honest and realistic view of AI, where it is today and where it can go. And what you see, if you can see it on this chart, is that you have 4 characteristics they've defined of AI: perceiving, learning, abstracting, and reasoning. And they have ranked, if you will, by the blue bars, the status of the wave as its ability to approach these 4 cognitive capabilities. So I'll give you a moment just to look at that. There have been 3 waves, or are 3 waves so far. That doesn't mean there will only be 3 waves. We see that the first wave was about handcrafted knowledge. And I think this was right after this point in time, we had what might have been one of the first AI or the second AI winter. Handcrafted knowledge was our desire. Let's take doctors for a moment. Any doctors in the room? Physicians? Medical doctors? All right. Area 1. Okay. Well, then we can talk about them. Perfect. So, well, doctors actually are pretty clever because they use experience-based reasoning, right? They have all these rules. They know exactly the characteristics of a cold or a fever or other diseases that they specialize in. But you walk in the room, and the first thing they do is size you up, and they look at you, and they look at your complexion and your body and just your physicality and a variety of things and make an assessment. And they do that based on experience of patient A, patient B, patient C, patient D, et cetera. They're probably doing some similarity analysis in there as well. You look like a healthy person. You're not. You remind me of this patient I saw 2 weeks ago, or not. Those kinds of things are going on. A lot of tacit knowledge in doctors, in other words. A lot of knowledge they can't even explain, that they have that they can't explain. You all have it in your day-to-day lives. Tacit knowledge that if you were asked to write down everything you know, inevitably you'd leave it all out. And that's exactly what happened in the first wave. Humans were expected to write down how you do things, what you know, how you know it, document it, create a knowledge system from it, and eureka, all the answers on how to be the best doctor or the best whatever would be available to you. Well, it didn't quite work that way because a lot of information was left out as a result. Now, today, the good news is that machine learning is learning that for us, is helping us create that. So it helps us identify information and data that we don't even know exists in the data. It's not unlike our tacit knowledge. So knowledge systems are much better today, but in the first wave, they were a dismal failure, according to the people who were there on the ground and trying to use them. The second wave is what I think of as deep learning, but here described as statistical learning. And deep learning is an advancement of the second wave, and as we exit the second wave and move into the third, it will have been a huge contributor to success in the second wave. So the big part about the second wave is that it's very, very data dependent. It relies heavily on training, models and training for the most part. It's generally speaking supervised learning as opposed to unsupervised learning, although that is not always true. There is and as the second wave of AI advances, unsupervised learning becomes more central to this particular wave. We think about this wave as perceptual computing as well. A lot of the work we did at Intel, for example, was centered was centered here in visual cognition. So organizations like Movidius are able to deploy visual cognition in various devices in order to understand the world in front of us. And if you're in the oil industry or in the utility industry, or even in the insurance industry and doing inspections of any kind, you're probably today deploying some form of visual cognition, deep learning assisted devices that help you survey the landscape, whatever that might be. So the second wave has been what we would think of as very successful and has added a lot of value to business and to healthcare and to government and military and other organizations. The third wave is really where we begin to have more complete intelligence, and as I refer to as end-to-end systematic approaches to decision making. And in this particular wave, we're going to add into it not just a deep learning, not just statistical machine learning, we're going to add into it reasoning systems that are contextually adaptive, that learn on the fly in real time, that incorporate things like one-shot learning. We'll talk about that in a moment. And they will allow us to have a more complete picture of the world, and they will allow us to make what we think of as more complex end-to-end decisions about how to take care of a patient, about how to solve, I'll give you an example of an airline problem of unplanned maintenance. So when an airline has an unplanned maintenance problem, they have to classify it according to ATA codes. And I believe those codes are at least 6 digits. They go from 4 to 6, possibly 8. Really hard to do for humans to get down to that level of precision. Takes a lot of time and resource to do so. But if you can understand, first we have to classify them properly with as high accuracy as possible in order to report them. But if you could understand them in context of what caused the problem, right? So causal analysis, if you could understand them in terms of how to take this particular unplanned maintenance item, now incorporate it automatically into your planned maintenance, your scheduled maintenance program. If you could understand the impact on your supply chain by knowing where else this will happen in your fleet. These are additional thought processes that must occur or should occur after an ATA classification of an unplanned maintenance event. But today, the systematic approach to doing that, which it could be an AI-driven systematic approach, doesn't exist. So these are the types of things that we wish to build in the enterprise for complete thinking through from the identification of a problem to resolving the problem and anticipating where else it will occur and resolving that in advance of it occurring, as well as building out the support systems to supply it and to maintain it. That's what we mean by contextual adaptation, and that's what we mean by end-to-end systems. You may have read the book, The Master Algorithm by Pedro Dominguez. If you haven't, I think it's a very good book to just get some grounding on the different types of learners and their purpose in the world. This particular slide attempts to give you an orientation to that, and this presentation will be available to you, which is why there's a lot of detail on these slides. But there are 5 major thoughts about how learning is done from an algorithmic approach. Generally speaking, these are also sort of religious. in their context. You'll meet a Bayesian who will debate an evolutionary and a connectionist, et cetera, and there will be hot, fiery debates occur. Fortunately, I'm in the camp where they can all work together. And then end-to-end systems that you will be using in the future, if you're not already using them, will in fact use a variety of these methods to solve problems. Today, deep learning is in the center. It's like what we think of as connectionists. The connectionist algorithms are there. And Google DeepMind is one I use as a really strong, well-known public example of a deep learning focused business model. And knowledgeizers is where I come from. These are my roots in machine learning. This is similarity-based reasoning, the ability to reason from experience. Symbolists are what we have more traditionally used for rules and models creation and are an important part of this suite of knowledge. And then the Bayesians and the evolutionaries sort of combine with, the Bayesians in particular, is more probabilistic in nature. And we really like the idea of Bayesian and analogizers coming together for causal analysis, for example. There's some power there. And on it goes. So these 5 are really the foundation for what we think of as a platform that we apply to solving enterprise problems. I put this example up for you just to talk about a couple things here. This is an example of a platform deployed while I was at Intel and through my team's work. What we would learn and have reinforced for us over and over again in the last 3 years is that 80% of the work we were doing was really over here on what would be your left-hand side. It's the data side. And data is complicated for every major corporate environment, every major enterprise environment. There's data everywhere. And there are acquisitions that have been done. And so legacy data associated with acquisitions never merge into the normalized new corporation, and on it goes. Examples of where data lives that could be important to us, but is not immediately available. So what we call data wrangling is where we spend 80% or have been spending 80% of the implementation time to get to production. And I hear some heads nodding here for people who have experience with that. So solving that problem is really important. And there are some organizations in the world trying to solve that problem to make this easier, from just the way data is stored to the way data is used and provided to you in advance of coming into the enterprise. So anytime IBM does this really well, anytime content can be acquired and assembled and organized in such a way that knowledge is naturally transferable to you, then that makes this whole process of learning from that and using that content for knowledge gain very effective, both economically as well as in time. The onward we go, so as we go through the rest of this process, basically what we were doing here is a workflow that said we got to get the data organized. You don't necessarily, in our particular case, have to model it, but we have to organize it and put it into a knowledge structure that's usable by you. And then from there, we can do query development. We can build out thought processes. We can add in visualization. We can build products on top of it, which we did, and deliver those to the enterprise. But the steps that you see along the way have been pretty traditional in machine learning, open source machine learning platforms that are trying to move you from data acquisition to some decision-making process. This is not unusual to see this amount of flow and work steps along the way. What we heard from customers over and over again is that please bring us some products that take care of all this for us so that we don't have to do it. And so you see today a lot of new AI companies being formed are very much focused on problem solving, bring in end user product to you so that you don't have to have the data scientists, you don't have to do the data wrangling. All of that's been thought through for you. And I think we'll see more and more of that over the next 3 to 5 years. And certainly there's an insurgence of that now. One of the things that has not yet really, in my humble opinion, been well adopted through these platforms is the continuous feedback loops, the one-shot learning part of that. And I think, let me just hop over to what do I mean by one-shot learning. Today, we train, deep learning is well known for requiring thousands, if not millions, of examples. A child can learn a tiger the pattern of a tiger in one shot. That's a tiger. Okay, got it. Next time they see a tiger, that's a tiger. Got it. We don't have to teach them over and over again. To teach a machine that what a tiger looks like could take thousands, millions of repetitions before it's finally understood and captured. And that's true. So machines are really good at some things and humans are really good at others. We're really good at one-shot learning. We need to bring this to our systems so we can be contextually adaptive, because sometimes, particularly when you're in an intelligence community, you're in the field of battle, you're in a complex industrial situation, one-shot learning really matters. And we need to be able to recall something that happened from the past and that may have happened 5 years ago and use it now, because it is exactly the same situation. And we should have that knowledge available to us. We shouldn't have to model it. And so that's part of the adaptive nature of systems of the future. Now, moving back, what do I mean by cognitive synergy? From our brain, what it means to me, not being a neuroscientist, is it means that we have an example would be we have a hippocampus and a neocortex. And my understanding of these things, neocortex is where our stable world exists, right? It's where we know things. We know what the tiger looks like. We know what this room looks like. We understand that this is a conference room when we're in a meeting. That's basic information that we've learned over time. The hippocampus is a thing that's kind of ingesting new real-time information and learning from it and determining perhaps if we've seen something before. So when we do analogical reasoning, for example, the process that we think about is, have I seen this before? Yes or no. If no, then it may be novel. We've never seen it before. Or no, it may be I've seen it before, but never in this situation, which would be anomalous. So we have the ability to immediately make those decisions on the fly in real time. From there, we decide what we're going to do about it. Do I need to do anything? Maybe not. Maybe I do. What have I done before? And maybe my experience, I don't have any, but maybe my friend does. So I can use the wisdom of experience from my organization to help inform me as to what to do with this particular problem. And that's part of the whole value of knowledge, creating knowledge graphs, and being able to reuse knowledge, the wisdom of your organization for new people or for experiences you've never had before. So machine learning, global stable patterns, important. The ability to adapt with situations, to understand relationships, the context of those relationships, potential outcomes, and to learn from those outcomes are merged together in cognitive synergy. And that's really what, to a large degree, what DARPA is trying to accomplish with the third wave. Another way of looking at that, for those who like stacks, is to, and there are a few of you out there, I know you're there, is to think about the movement this is a wave of moving from, kind of pre-AI, business intelligence as we knew it at that point in time, moving into today's solutions of inferencing, model memories, learning from that, various machine learners that we talked about earlier, to reasoning and associative memory systems, and onward to combining them into one systematic approach. That's the future. That's what enterprise systems will look like in the next few years. In addition to that, there's a new democratization occurring about decision making, and which I love. Having grown up in the enterprise software world, where we designed rules to help make decisions so that workers couldn't make the wrong decision. Think about that, right? All the enterprise systems really were designed in the 90s to make sure that the right decision would be made, and sometimes to make that decision for you. The world we are living in now, and the world that we're creating with AI, suggests that decisions will be made by the worker on the fly in real time with you. So if you're a consumer and you're talking to someone, the worst thing that can happen to you is to be put on hold while they try to figure out what to do by talking to 3 supervisors or whatever it takes to do that. Or maybe the worst thing that can happen is they say, I'm sorry, no, I can't do that. I was actually in a retail store one day when I was trying to return something, and they couldn't actually, the system would not allow them to make that return just because they had not thought about doing it that way before. And this happens to us all the time as consumers. So the future says we have a lot more flexibility, a lot more adaptability. But I like to think of this as the human-machine interaction and the different ways that we are, as simply stated here, that we are going to interact with machines as workers and making decisions, as making sense of the world in front of us, and deciding what to do next. I originally developed this for the problem of anti-money laundering and thinking about where do you have situations where suspicious activity reports can be automatically filed versus those that need to be investigated and verified before they're filed. And so in working with a banking organization, we talked about where we instruct to find out more information. We give an intelligent agent information to go search for us, bring us back their findings, so we can use that information to make decisions, versus collaborating. So one's very directed, right? So it's a query, right? Think about that, just like writing a query. Go do this, bring me back this information. Collaborations, now we're bringing in speech or interactive dialogue between a machine and a human, and we're actually having a discourse on how we resolve a problem. That is in use in some instances today, but not widely used. In the future, it will be widely used. So it's not you talking to your phone and asking it to look something up on the web for you, but actually having a discussion about what's the best path to go from A to B, as a simple example. In the work environment, it is the idea that as I was preparing for today's talk, I went out and looked at what's happening in the news. There's a lot happening in the news around AI. And I can't imagine being someone not in the industry and trying to keep up with that. But I would love to have my intelligent agent work for me and help me prepare for this talk and find the most relevant topics, given the focus of the conference, in order to present to you the most relevant information to take home. I don't have that intelligent agent, maybe something I need to build, but nevertheless, that ability to collaborate, have a discussion, have an actual discourse on something, and together assemble a report, an intelligence report for that matter, would be a wonderful adaptation of the future. And then finally, delegating. There are some decisions that can be delegated to machines. And therefore, when there's a degree of certainty around something, we can have the machine go ahead and take action. And that's sometime in the future for many things, certainly in the criminal area, the legal area. That would be an interesting discussion as to when you can do that and when you should not do that. But all of these things need to be transparent and explainable. And one of the things I haven't really touched on yet is that transparency of how the algorithm works and explainability of what data was used to get to the conclusion is in fact a requirement for every enterprise system and should be demanded by you of your vendors. It is in fact in some countries being legislated, regulated in, particularly when the decisions involve humans, as it should be. And that leads us to topics around ethics and bias. So inclusivity does matter, and you've probably read many articles and have had some dinner discussions with friends about the bias of AI, and there are many people working on this today, and we're going to see some great improvements over the next 3 to 5 years, and if not immediately. The coded gaze is an expression that it simply means subtle bias for race and gender, and is created by the mere fact that the engineers themselves are of a particular race and gender. And it doesn't mean they're all white. It just simply means that they are of a given race and gender, and that therefore bias naturally comes into the way they think, the way they code. Right. So there's some people like Joy Buolamwini, who is at MIT Media and also formed the Algorithmic Justice League, who are serious about this and making sure that she blogs about it, she talks about it, and raising awareness of this issue. There are great organizations like IBM and Intel and Microsoft and Google and others who are working on this problem also and trying to create some standards, if you will, around this. There are academics who are working on teaching bias or unteaching bias, as the case may be, in academic computer science programs. So I would believe it's in a nascent state at this time, but great progress being made at a fairly high rate of acceleration here. We're all responsible, even as consumers, we're responsible for calling out bias when we see it and acknowledging that it can exist and making whomever that we're engaging with aware that we believe that there is bias. Today, banks this is a highly sensitive topic for how loans are approved. It should be a highly sensitive topic for how people are hired, because there are algorithms working all the time to do resume selection, and we don't quite understand how they're making those selections. So that's also an area where we see it affecting us on a day-to-day basis. I love that Microsoft has just announced a new chief AI ethicist in the organization, so they're taking it very seriously. He goes on to say that a lot of people with formal education in engineering and science did not have any formal education of ethics. I certainly didn't. And so, I believe many in this room probably didn't either. You got it a different way. So nevertheless, this is a big and important issue, and Tim O'Brien's on the job now at Microsoft. Finally, I'm going to conclude with just a couple of points on explainability. DARPA is also leading the way here as part of the third wave to have explainable AI. They've anointed that XAI. Just to explain how this works today, we are working through a machine learning process of training data. We use the machine learning process itself, the algorithmic process. We have a learned function. We tell you what it is. We can't explain it. You don't understand. Why did the program do that? Why is it telling me that? When does this work? When does it not work, et cetera? The types of things you would naturally want to know the answers to. This is hard to have the transparency to get to these answers. And in the future, if we look below, everything is based on an explainable model where the data is available for examination, where the algorithm itself has transparency, we understand how it works. And then finally, we can answer the question as to the why. Why are you recommending this? What's the substance behind it? And therefore begin to trust the systems enough that we are using to support the decisions that we're making, and also get to that point of delegation. It's hard to delegate decision making to a machine if we can't understand how the machine's making the decision. So until we have that, we can't progress much in that area. I think the new battlefield, frankly, and I've thought this for some time, is data and our own lack of ownership of data. So I want my medical data. Thank you. I actually want to understand my buying patterns in a way that's much more granular than my credit card can tell me. Because I have multiple credit cards, I have multiple financial institutions I work with, so we need that consolidated together to have good financial planning, to get financial wellness planning, to have health wellness planning, to have family planning. There's a lot of data that's today very much fragmented and isn't available to us for consolidation, unification. We're going to see data privacy being taken much more seriously than it has been. Microsoft has been leading the way. This particular note is from 2015. And they continue to advance the state of privacy and for you, personalized privacy, as they move forward. Yesterday, excuse me, or the day before, I felt this article is really important and sort of exciting. So blockchain and AI are two of the noisiest expressions in the universe, right? Right? If we had $1 for every time one of them is said, we'd all be very wealthy people. But there are startups working and bringing blockchain into the idea of democratizing access to data. And this is very new, and there are a few startups both in Europe and here in the United States working on this, but the ability to allow AI networks to access these large stores of data without big company control. So if you're one of those big companies, this is a point of disruption. I think it's a really important point of disruption for us as individuals, and the potential to benefit us all in the future if it's executed well. So I would love to leave you with some brilliant inspirational comments, but I'm going to instead not be a downer here, but actually ground us in reality. There are so many exciting things ahead. This is very, very hard work. There's nothing that we've described up here that is going to happen instantly. It takes a lot of smart people, it takes smart customers, the willingness, the funding to invest in this and many other resources. So Reinhold says that when you're climbing a mountain, despite your study, despite your planning, It is always further than it looks, it's always taller than it looks, and it's always harder than it looks. And having been in the enterprise software business all of my life, I will agree that there hasn't been any new project, any new complex end-to-end systematic project that didn't fit this characteristic. Now, once we learn how to do it and we have repeatability, then it gets better, but we're still very much in the early nascent state of AI and its implications for the business and for us as individuals. And I look forward to being part of that society and to helping further it and advance it as we go. So thank you very much for your time today. I do appreciate it.
Great. So we have about maybe 10 minutes for questions from the audience. So we'll send some mics around. If you have a question, just go ahead and raise your hand and we'll bring a mic over to you.
I'm Joe Fox from Ashland, and this is kind of an abstract question, but I'd just like to get your perspective on it. About a year ago, I saw a video with 2 robots in it. Okay. And the first robot was a short one, and it had come up to a door that it couldn't open. And so what it does is call a bigger robot that then opens the door. And I sat there and thought, wow, this is just amazing. But as I've kind of understood this a little bit more in the last year, it's like, is it only that door that they could do that on? If it had a handle rather than a doorknob, could they do it? How close is that to ultimately them being able to open any door, or how far along on the journey is all of this?
Well, I'm sure there's some research labs where they are trying to advance that. That requires contextual adaptation, right? It requires some form of reasoning on behalf of the robot. It requires learning on the fly in real time. It probably was more learned knowledge about if this, then that, right? Then I believe, but it depends. If it could have been an advanced laboratory where that, in fact, that was an experimentation of contextual reasoning adaptation of a robot. And that's what we should expect of the future is, in fact, that ability, whether it's commercially available today or not. But what you saw was an example of what they hope to create for the future, right? It's exactly what you saw. How they did it, I don't know.
You mentioned that some of the past AI approaches might have a reemergence. Where are knowledge-based systems or rule-based systems now, and do you expect them to play a significant role in the future?
Right. So I think rules will never go away. Our society operates on rules. We adapt, but we operate on rules. Our Constitution is a great example of that. I think we're going to see rule systems survive and thrive in the domains they belong in. We're going to see some rules be adapted based on learning that's occurring in the world, our worlds, our business worlds, or whatever they might be. So rule adaptation becomes more natural. Today, one has to have many observations to understand that a rule is wrong, that a rule is outdated, that a rule is not complete. And so what we'll see is the ability to adapt those rules better for our workers, for our customers, for our suppliers or whomever. So I think that's one of the transitions we're going to see that I look forward to. But I don't think they go away necessarily because we have to operate with some guidelines and some basic foundations of structure in our society. Did that answer your question? Yeah. Okay. Yes. The symbolists are one of those machine learning tribes, for example, and I expect them to be very much alive. So I think in some industries like regulated industries, banking, when we are dealing with a money laundering problem, a fraud problem, or whatever it might be, there are some rules that we're going to have to follow that are regulated, and we will. And they will become they're part of the system logic of how we operate. But there may be some other aspects of that that are more contextual in orientation. So it's just understanding the customer, right? And the customer's episodic behavior and whether or not that qualifies as a money laundering activity. That requires more of contextual reasoning systems. And then the rule systems are obviously being, if you will, litigated in that decision process.
Good morning.
Good morning.
Yeah, that was a great talk.
Thank you.
Steve Brown, Boeing. As far as AI goes, my imagination goes to where I think somewhere in DARPA, in a locked up lab, there's some scientists talking to a computer and it's talking back and giving them new information.
I hope so.
We'd like to think that, but it kind of troubled me that you, being a leader in AI and Intel, admitted you did not have any help with your talk today from an AI system.
Right.
And so, you know, as maybe just a secret indication that there really is none. Are you aware that we're getting close? What is the measure when you actually would say, no, these people seem to have crossed the barrier? What is that metric?
Yeah, great question. So because it takes us to some of the things we see with Amazon and Apple entering the enterprise with dialogue systems, Alexa and Siri, for example. So the only reason why I'm unemployed. I have no technology available to me and very little time. So if I had my old technology wallet at Intel, I could have gotten much further because I would have created a knowledge base very quickly around this talk, which would have helped. Now, it wouldn't have been a human dialogue, interaction, collaboration, but I would have at least been very directed in what I wanted it to go get for me and bring back and organize. Okay. But I think the part of this is we see Salesforce, I think, announced Alexa, using Alexa, bringing that into their work in CRM. And this is an important step forward to getting to human-machine interaction and collaboration, because now we're having a dialogue. And when we have a dialogue, that's going to be a little easier than having to type out the right query or the right sequence of attributes that we wanted to search on. And so we're not far, I don't think we're far away from that at all. The human-machine interaction collaboration side of it is on top of us. I think even IBM's got some stuff underway there.
Steve Johnson from Timken. So the little bit of reading I've done on deep learning, this point you were just making at the end of the talk there on sort of explicable AI intrigues me, because part of the challenge of, you know, the human trust of the machine and whatever decision or recommendations the machine is making. You know, the bit I've read about deep learning, by definition, once you get a few layers deep into these systems, the mathematical relationships that it's drawing of the data are sort of nonsensical to human beings and therefore inexplicable. So I'm intrigued by, do you have any insights as to how DARPA is actually going to approach that? Do they need another AI system to interpret you know, the deep learning system, for example? That's
what I've heard the answer is, not from DARPA, but from others, is that algorithms are being developed to understand, to decipher the algorithms used in a deep learning scenario, for example. So, yeah, that is underway, and by a variety of people. It's the ability to explain that. And they're using AI approaches to do so. There are some that are more easily transparent than the traditional convolutional network approach, neural network approach that we have in deep learning, with many, 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 many layers where we lose the transparency. But one way to do that is to use an algorithmic approach. So you do know. Yeah.
Hi, Ryan with Nate. You're talking a lot about the future, where this is going, the third wave and all that. Who's developing? Who's going to get us there? Is this a bunch of different private corporations working in silos, or government organizations like DARPA that are going to, you know, deliver this and bring it to the world? Or is there any opportunities for this to be a community-driven thing? Like, who's going to control this when it's out, and where is it all going to come from? I guess is kind of where I'm scratching my head with it.
All right, we're going to get the crystal ball out now on that one. All right. Well, I think in all great transformations that we've accomplished, there are new co's doing it. There's some DARPA funding, which is encouraging new institutions as well as existing organizations to invest and build and research. And there are some large organizations, I imagine, that are well down the path, that are independently funded, and they will remain unnamed. So it's a combination of those things. One of the goals I have, frankly, from a new AI Co, which is a stealth name for this new company we're forming, is in fact to advance as fast as possible from a new position, right? So no legacy to worry about, no formal tech to worry about. You get to go in fresh perspective on it. Can't do that alone, though. That requires collaboration with others, no doubt. I don't expect that we'll do that on our own individually without collaborating with academia as well as other technology partners to accomplish it. It's pretty complicated, and there are many pieces to it if you think about an end-to-end system, from speech dialogue systems that are very capable, natural language processing and understanding, a huge part of this, to advancing algorithmic science for how we analyze a problem. We have a lot of work to do still, but a lot of people are working on it, I do believe.
I think we have time for one last question.
Yeah, Scott Huffer, Sunoco. Can you comment on how quantum computers are making an impact in this area?
You know, I really can't. That is not my area of expertise, other than to expect that there will be a significant impact, right? And the timing of that, though, is still not clear to me. So maybe someone else who's speaking here today and tomorrow who can clarify that for us better. Thank you.
So since that was a quick question, I'll ask one last one.
Okay.
You alluded to privacy as being a critical issue right at the end of the talk.
Yeah.
And so systems you can set up with rules and base, but people don't have rules. So I'm wondering, what do you think the tipping point will be that will drive some consensus about how privacy? Will it be regulations? Will it be company leadership? Or do you think public outcry from some event will make the tipping point where this becomes like a real pressing concern?
All three. I think all of those things will occur. One is I think we should be more demanding as consumers of access to our data. And we can help lead the way. We can push that. We can talk about it. We can lobby for it. Government in Europe is on this. So we see government taking the leadership role there. In the United States, we haven't seen that yet, but we've seen some corporations try to lead the way. So it's probably a combination of some legislation, some regulatory action, some consumer action, and some business benevolence and action is going to be necessary. And new codes starting up are adopting this. So they will, in fact, disrupt current businesses and force eventually some form of transformation, I hope. So that's my optimism for that. I do believe it's an important part of the future, and that it is a battlefield yet to be won by the consumer. So thank you again for your time today. I do appreciate it. Thank you.